In this video, we are going to interpret a network diagram.
Imagine this scenario. The network administrator at your company has retired, so you have to take his place. Let's say you were previously responsible only for the end users, so you didn't have to worry about the entire network. But now, you'll be responsible for everything. You'll have to be the one that solves all the problems that occur. And you'll also be the one redesigning the network and making improvements, upgrades, and so on. All of a sudden, you will have to know everything about your network. Which devices are there, how they're interconnected, what their IP addresses are, and much more. So as a good network administrator, it's your priority to have a thorough understanding of how your network is built. You have to know what you're working with, right? Or actually, anybody that will work after you, or instead of you if you're on PTO. Basically what you need is a network diagram, a map of your network. So when you start off as a network administrator, you have to first build such a map if it hasn't been done before. But if you already have a map, then you have to check if the existing documentation is correct. And usually, documentation isn't purely a representation of the physical topology or the logical topology, but it's usually something in between. Which map of the network will you use when you try to troubleshoot an IP phone connection somewhere in the network? You don't need the exact path of a cable through the hallway. However, it is good to know on which port on a switch that cable connects to. And that's where a network diagram comes in handy. Well, based on the information that you have, can you guess what we represent in our network diagram? First, different network devices, of course. When looking at the network diagram, you can find several icons depending on the devices that you have in your network. PCs, IP phones, switches, access points, wireless LAN controllers, routers, servers, firewalls, and so on. But if you had only devices on the diagram and nothing else, this information wouldn't be useful, right? If we go back to our previous example of troubleshooting an IP phone connection, how would you determine to which switch this port is connected to? For this reason, besides devices, we also include other information on this network diagram. Combining all that information is what makes the network diagram really useful. So it's common to identify the interconnections between devices along with the interface identification. If you take a look at our network diagram, you can see different interface identifications. S0/0 is a format used for a serial interface. Can you name any other? You see FA0/5 or FA0/6 and so on, right? Those are formats used to identify fast Ethernet interfaces. You can also see GI0/0 and GI0/1. Can you guess what those are? Yes, they're identifications for gigabit Ethernet interfaces. Besides the interface identification, it is common to include the network address of the segment on the diagram. In our example, you can see the 192.168.1.0/24 network segment. Here the IP address 192.168.1.0 indicates the network address and the /24 indicates the subnet mask. But the network segment as such doesn't tell you much, so you normally include also the exact IP addresses on the interfaces. So in our example, .1 and .2 at the device ends indicate the IP addresses of the interfaces. To get the IP address, simply replace the 0 in the network address with the number and you get your interface address. The router's IP address in our example will be 192.168.1.2. So this is the information that you can find on a network diagram: the devices, their interconnections, interfaces, and IP addresses on the segment of end devices. This example we showed here is just one option of how to make a network diagram. If you don't include all parameters we listed, or you mark them differently, it doesn't matter. What matters is that you understand it and you get all the information you need so that you will know what you're working with.